we're going to look at in this section slope and average rate of change. So slope is another way of that. It's rate of change. And in the case of a line, the slope is both the instantaneous and the average rate of change. But generally speaking, this formula is how you would calculate an average rate of change. So what we mean by rate of change is your change in your y or your dependent variable relative to your change in x or your independent variable. So the notation we usually use for slope is m, and then the way you calculate it, if you're given 2 points, so let's say we have point 1, we'll call x1 comma y1, and point 2, which we'll call x2 comma y2. And then the way you calculate the slope, change in y, so y2 minus y1 over the change in x, x2 minus x1. Now just keep in mind that if you're dividing by 0, that's an undefined slope, whereas if you have 0 on top and non-zero on the bottom, then that just means the slope is equal to 0, which is like if you're talking about a line, you're talking about a horizontal line. So let's say you're asked to find the slope of the line passing through the points -4, 3, and 5, -7. Okay. So again, anytime you run into a formula, you probably want to start off by just writing out the formula. Then take a step and start filling in the numbers. So y2, so -7 minus y1, 3 over x2 minus x1. So -7 and -3 make it -10 over 5 minus -4 is the same as 5 plus 4, so 9, so -10/9. That's our slope. So it can come out to be a whole number or an integer. It can come out to be some fraction, whether proper or improper, whatever. Now, if you're graphing it, you probably want to use it in the an improper fraction form versus like a mixed number. But other than that, it doesn't make any difference. So that's how you calculate slope. Now, the thing with a line, for a line, no matter which 2 points you pick on that line, if I pick 2 points here and I figure out the slope is exactly the same as if I pick 2 points over here. It's the exact same slope as if I pick, say this point and this point, and I figure out it's the exact same slope everywhere. So for a line, the slope is constant. It's always the same number. Now, when you start getting into more complicated type of functions, what we see is if I calculate the slope here between these 2 points, that's going to be a totally different answer than if I try to use, say, these 2 points and calculate a slope. Now, that's going to be a different answer than if I use, let's say, this point and that point over there. That's going to be an entirely different answer. So in that case, what happens here is the slope is changing over time. It's a positive slope, and then it kind of goes to 0, and then it has a negative slope, and then it goes back to 0, and has a positive slope. And so what you can do is you can figure out, there's techniques to figure out what's the slope here versus what's the slope here versus what's the slope here. But that requires calculus, and so obviously we're not going to get into that. So what we're going to look at is the average rate of change. In other words, what's the slope look like on average? So to find the average rate of change, the way you would calculate this I'm just going to use slope, m for slope again, is f of x2 minus f of x1 over x2 minus x1. Now, remember, when we're talking about functions, y and f of x are basically the same thing, right? So this is really saying the y value for the second x and the y value for the first x. Well, that's exactly what we did here. Is what's y2? Well, y2 is the y value for the second x, and y1 is the y value for the first x. So if I'm going to find average rate of change, and this is just slope, that's all it is. But you need 2 points to do it. So let's say they gave me a function, f of x equals, let's say 2x cubed minus 5x plus 1. And they want us to find, what's the average rate of change when x1 is -2 and x2 is 3. Okay? So what I'm going to do is I'm going to start off by saying, well, what if x, it has a value of -2? So what's going on here? So 2 cubed minus 5 times -2 plus 1. Again, this has function notation. We're just plugging that in. We're going to work it out. -2 cubed is going to be -8 times 2. So -16. -5 and -2 make a +10 plus 1. So looks like what? -6 plus 1, -5. So there is a point on this curve where the x value is -2 and the y value is -5. So there's 1 point. So then I need a second point. And so I'm going to plug in 3. Going back to this equation, 2 times 3 cubed minus 5 times 3 plus 1. So 3 to the third, 27, times 2 is 54, minus 15 plus 1. So let's see, 54 plus 1 is 55, minus 15 is 40. So when x was 3, y was 40. So now I'm just looking at these 2 points, and all I'm going to do is slope. I'm just going to use these two and calculate slope. So 40 minus -5 over 3 minus -2. y2 minus y1 over x2 minus x1. Well, that is 45. That is 5. 45 divided by 5. So the average rate of change from going from x1 to x2 is 9. So in other words, this curve has an, from whatever that point is to that point, if we were to draw a line just connecting those two, however the rest of the curve kind of does its thing, if we just draw a line connecting those, that would average out to be a slope of 9, up 9 over 1, up 9 over 1. All right, and that's it. All there is to slope and average rate